So I'd like to thank all our speakers in that abstract presentation and Dr. Newington for his presentation prior to that. And we now move into the last part of our day, which is the introduction to the panel discussion that is going to be led by my colleague and friend, David Cole. David is the co-founder of Thinking of Oscar and also Europe, Middle East and Africa leader for IBM Healthcare Consulting. And joining him at the panel discussion is Dr. Alberto Tosi. Alberto is a pediatrician and epidemiologist at Bambino Gesù Children's Hospital in Italy. And also Dr. Timothy Chow. He is the Bevel Cloud founder and lecturer on cloud computing at Stanford University in the USA. Thank you, David, Alberto, and Timothy.
Good afternoon.
Good morning and afternoon, everybody.
Hello, I can't hear you.
Just a quick check. Can you hear me? We can't hear each other.
Now? Can you hear me?
I heard Alberto.
Yes, good. We are.
We can hear.
We made it. Good.
Okay.
Fantastic. Well, so good afternoon, Alberto, and good morning to you, Timothy. Thank you for joining us here at this panel session. And I think we've all been looking forward to this for a while. So without further ado, we'll kick on. Now, the theme and the kind of abstract that we've picked for this session is moonshot mission. Now, those words have been used a lot over the years, so we'll put some more context around it. But we're looking at the transformative power of healthcare data sharing. Now, before we go into the important bits, I haven't prepped you guys on this, but I thought I would ask you a bit of an open question, just so for the audience they can get to know you a little bit more. So, Alberto, tell me, when you were growing up, what did you want to be?
I want to be an engineer, actually. I did not want to be a doctor. I was thinking about technology, radio. This was one of my favorite hobbies. I was trying to connect with other people from remote. That was pretty, fun. When I was young, connecting to people thousands of kilometers away was really exciting. And also trying to find out the right solution, the right technology for doing that.
Fantastic. Well, it looks as though you managed to bring those two things together.
Exactly.
Wonderful. So, Tim, same question to you. Same question. So what did you want to be when you were growing up?
I should say I wanted to be a doctor so we could keep. No, I think, from a very early age, I discovered computers and thought they were amazingly interesting. So I've been on that path for a lot of years now, so I haven't really deviated. And computers have been an interesting area for a lot of years.
All good, absolutely, and we'll get into that a little bit more. So, neither of you guys will kind of respond to this, but what I wanted to be when I was growing up was a professional cricketer. That didn't happen, so we move on quickly. So Alberto, give us a couple of minutes just in terms of the work that you do. So Paul introduced us, but give us a little bit of a snapshot as to the work that you do, both with Bambino Gesù, but also with iSpy.
Yeah. Well, I'm lucky enough to be a pediatrician, so my work is with children, which is one of the best things you can do, whatever you do. But actually, the most exciting things is that you take care of children for making the best of them. And the same idea is present, and we are pursuing the same objective if we are speaking of drugs, of procedures, or technology. And this is one of the focuses. Well, as a pediatrician, I've been working in this hospital, Bambino Gesù Hospital, which is in Rome, Italy, for quite a lot. It's now 18 years. And I not only I have responsibility in research activities, but also in innovation projects. And this was the main reason why several years ago I met some people in the US. These people are from this strange scientific society called the International Society for Pediatric Innovation. And it turns out that since the beginning of this year, I'm the president of this scientific society, which is pretty challenging because actually putting together all the mindsets coming from different countries and different backgrounds is one of the most difficult things. That is also one of the most exciting things. So we're trying to bring together all these things to do the best for our children.
Fantastic, and that's where you and I met as well. We were at an iSpy conference in Miami, and they said, "Look, 2 Europeans, we'll push them together, see what happens." Fortunately, we became good friends, and we continue to do so. So Tim, talk to us a little bit about your background, but then if you could move into Bevel Cloud, I think that probably sets the scene pretty well in terms of the conversation that we're going to be having now.
Yeah, well, and it'll intersect with why I met you, David, and why I met Alberto too. So I've had a long career in computer software, as I kind of indicated. My last full-time job, I was running the cloud computing business for Oracle. And now, it's been a while, 15 years ago, I left. And I had been teaching in a prior life there, actually core computer architecture classes. And so the department said, "Oh, come back and teach again." I was like, "That's a lot of work." So they said, "Teach a seminar class." So I went, "Okay, I've been a manager a lot of years, great opportunity, great people, put them together, and I don't have to do any work, right?" So we started this class. It's called Cloud Computing. For those of you interested, cs309a.stanford.edu. I actually took a 2-year hiatus during the pandemic. We're going to do it again in the fall. But this class is really the origin story of how this all, at least for me, came together, because I'll say 6 years ago, this guy shows up in class, and turns out he has an MD, an MPH, an MBA, and he's chief of pediatric cardiology at Children's Hospital in Orange County. So some of you know Dr. Anthony Chang. But Anthony was in town, amazingly enough, to get a master's degree in bioinformatics. So I don't know exactly how old he was at the time, but I'll say he's in his early 50s. It takes him 3.5 years to finish a 2-year program because, number one, he has no idea how to code. Number two, he has a real job as chief of pediatric cardiology. And number three, as some of you know, he decides to adopt an 18-month-old and a 6-month-old, and he's a bachelor. So I love telling Anthony's story because I always tell people it's never too late, right? So Anthony, very early on, invited me to iSpy. They do a conference called Pediatrics 2040, which I was happy to go to because he holds it at the Ritz-Carlton in Laguna Niguel, which is fabulous. So I show up. By that point in time, I have learned that there are about 500 children's hospitals in the world, and I'm pretty convinced there are like 200 of them in the room. And it was not the, administration people or whatever. It's like a pediatric endocrinologist that wants to talk to you about graph databases, right? So I thought this is pretty interesting. So over time, I would say I've been adopted by the community. I started to learn things like, oh, they still use CD-ROMs to pass data around. In fact, there's a story last year in Southern California, a kid went undiagnosed with brain cancer for a month because 2 hospitals and 1 clinic could not share an MRI scan, right? And in the world of tech, I'm like looking at this going, why, how come? And at the other end, and that's clearly why we are here today, the advances in AI, particularly in image processing, are heavily dependent on being able to acquire large data sets because that's the only way you can build these deep learning algorithms. And so the challenges of, well, how do I get a hold of that data? And so, as I said, being in the infrastructure software business for a lot of years, I'm looking at it going, this is not that hard a problem. So about 1.5 years ago, I brought together a team. As you can imagine, a bunch of guys that we've known each other and some women that we've known each other for quite some time. And we basically set ourselves a mission this so-called moonshot mission to create a new generation of pediatric applications based on access to data from all million healthcare machines in all 500 children's hospitals in the world. So when I'm saying, why am I saying 1 million? The rough number we kind of estimated is there's 2,000 machines in every children's hospital. Although I'll tell you right now, Stanford has 20,000, so that number might be an underestimate. And when I say machine, I mean everything: ultrasounds, MRI scanners, blood analyzers, ventilators, et cetera. And so we have been on that mission. I could talk a little bit about where we are right now, but along the way, because this is not a mission that can be done by one group of 10 people, it requires a community. And so, we've been very happy to have many in the clinical community, including Alberto and the Bambino Jesu tribe, join in because the mission is obviously ambitious, but I think is completely game-changing in terms of what it can do in, I'll say, rural California, in the Shetland Islands, in Kenya, as well as in Rome or San Francisco. If we could literally take the best brains, and we could take Anthony Chang's cardiology brain and put it in front of every child on the planet, I mean, that would change everything. And we have the capacity to do this. So we've been inviting people, and I will say that in this and at the end, to join our mission, whether that's on the clinical front or from the AI community, et cetera. I'd be happy to talk a lot about how we've developed a new methodology for being able to develop AI applications based on this infrastructure. And just to give you a little teaser, by June of this year, like next month, we believe we will have the capacity with what we are calling the Vanguard 10 hospitals to serve up over 100,000 ultrasound cases, over 140 terabytes of data for authorized applications to learn on, share, use, et cetera. It's unprecedented. I mean, right now, the NIH Imaging Data Commons project is at 30 terabytes. We're going to pass that, this year easily. And I'm just talking about 10 hospitals. If you start conceptualizing all 500, I've done a back of the envelope. The amount of data generated over 4 years would be 250,000 terabytes. So we need a new technology, and I'd be glad to talk about what we're doing in Bevel Cloud to be able to do this, because we don't think that building central repositories of data makes any sense, both from a privacy point of view, because if one of the central tenets of privacy, in fact, one of our team members is a former student who has 14 years of experience in privacy law. And one of the fundamentals is purpose limitation. And when you say I'm going to aggregate a bunch of data and you can't explain what you're doing it for, then how is that purpose limitation? And the second point to make is, and this is from years of experience in enterprise software, once you try to organize data, you will try to organize it in a schema. And at the end of the day, when you do that, you'll ultimately lock out the second application. And the third point to make is, does anybody really want to try to store and manage 250,000 terabytes of data? It just seems totally ridiculous. So anyway, I don't want to occupy the stage the whole time. That's kind of a brief on what we're doing, how we're doing it a little bit, and many of the team members that are part of this.
No, Tim, that's brilliant. I think that frames our conversation really, really well. And actually, my job, and I think our job today, is we can wax lyrical about the opportunities that we have with bringing all the data together, the research opportunities, just as you say, putting the best minds, using the data that we've got into the hands of pediatricians, clinicians, nurses across the world. But I think actually an interesting element, let's play devil's advocate for a little bit. So, Alberto, for you, first of all, talk about the opportunity that you see as a clinician for having this data in your, kind of at your fingertips, as it were. But then think about it, or give us an indication what you think in terms of the ethical side of things. So you've got lots of data being pushed into the cloud. Have we got authorization to do that? How do we use it? Give us a little indication as to your thoughts on that.
Yeah, well, there are a couple of things. My background is epidemiology, so I'm working with data, pencil and paper since I was very young. And my last 30 years of experience, we're facing the challenges of central repositories. We have been trying to do that all the time, and we never succeeded. So there were some stories of success doing central repositories, but they were not scalable. And we have to abandon those efforts once we changed our objective. That's very simple. So the first time I met Tim, I thought it was crazy, because actually it was completely against the possibility that I was working on all the time. So central repository, same standards, same data, and so on. Then I thought, come on, but this is much better, because you can change over time. You have the same technology and the same machines, the same sources of data, but you can change over time, and you can update in real time whatever you want, which is much better than trying to decide for one hypothesis and then staying just on that. And this is exactly what we need. There's one component that we should be aware. I think we have a tremendous opportunity from the point of view of methodology, because actually we have spent a lot of resources in preparing and supporting clinical trials, which is absolutely necessary. At the same time, we have now so many data sources that we should manage, and we should also understand which is the best methodology for driving the hypotheses that we need before doing clinical trials. This is one of the crucial things. Nobody's discussing that, but I think it's a very important point. Now, if I think of a never-ending resource in which I can make queries on all the sources of data I have in my hospital, this is beautiful. We all know, we doctors all know, that we're sitting on a huge amount of data that we don't use, never, simply because we can't, we don't have the necessary equipment and technology. So this is the very reason why this technology might be a game changer. So think of what's happening right now. And we recently finalized a review of artificial intelligence applications in pediatric oncology. Believe me, we reviewed some 400 papers. All of them were on single repositories. Sometimes there were 2 hospitals putting the data together. That's it. We can't do artificial intelligence application with this approach. And the most frequent word coming into these articles was, it's promising, which it's not something that we can use. So we must go much beyond those limitations. And I think we have now the opportunity, and we must try to make experiments to understand if this works. Now, about the ethics, you know that one of the obsessions that we have in the hospital is trying to negotiate with the data protection officer. He's sitting in the room beyond this wall, for example. We're discussing a lot about privacy, about the rules for, meeting the GDPR recommendations and other things. It's difficult, it's challenging, and we are slowing down so many processes for doing research, which seems to me, and we have shared this view with Anthony as well, it is unethical to slow down and stopping data sharing simply because of privacy problems. And let me tell you one thing, privacy is absolutely crucial, necessary, and so on. But we're moving the focus to a different problem. We should focus on patients and the communication with them and their families. Because actually, once we understand that they agree on sharing their data for doing something which is very well explained to them, we have a partnership. And actually, we can't be stopped by rules because everything will become much, much easier. So on one hand, I think that we as European Union have a lot of challenges that should be overcome. You know very well that we have recently received the announcement of this European health data space, which is a beautiful object. We don't know exactly what will be inside that, but hopefully we will be overcoming all the problems. But at the same time, we should work with patients. And I think this is the tricky observation for overcoming all the barriers that we are having right now. Once you have this partnership, and the patients allow you to use their data and they trust you, everything's done. So you have much less problem. Having said that, there's a third component that usually is intrinsic to the technology that we're using. You know, since we are using the infrastructures of each hospital, we have technology constraints and regulatory constraints, security constraints, depending on the infrastructure. So the point is, the team is making is, let's go to the data source, leave it out of the game, the infrastructure. You don't have this problem anymore. You just have a digital twin, which is close to the edge of the machine, and you can have your own micro algorithm very close to the machine. This means that one of the things that we can do is applying federated learning models for artificial intelligence, which is becoming a buzzword because every data protection officer is so happy about federated learning. They understand that we're not moving data outside the hospital, and that would be obviously one first step. Once we will find out a different way to share the data, we will go beyond that. But I think this is the very first objective that we are very close to, and we are excited to test, I think.
Alberto, you've hit every buzzword on my sheet, I think, there in what you've just said. But there's some really important elements to pick out. Digital twin, let's come back to that. Okay, what I actually want to touch on now is coming back to your kind of consent side of things and talking about how do we, or even do we, what do we need, and how do we get the right consent from patients and from hospitals in order to do this at the scale that really we need to do it to make it work? Tim, let me come to you first before I'm sure that Alberto has some views on that.
Yeah, let me touch on two things. One, in fact, as I said, one of our team members has 14 years of experience in privacy law, particularly around the GDPR. And just to make a comment, consent is not the only legal framework for sharing data. There are other frameworks like legitimate interest, et cetera. So I think a lot of times, this is my observation, and one of the reasons I started the class at Stanford was if we cannot educate the legal community on what we're trying to do and just treat it as a black box, we're not going to be successful. We're going to run into them left and right. And I think we need to, explain to them how this works. And also for us, I'll say on the tech side of this equation, understand the legal framework. So just to make that as a comment on the question of consent. Now, as Alberto so eloquently said, we have said, look, at the end of the day, the way we do AI today is kind of backwards. We go and aggregate a bunch of data. We take a bunch of AI engineers, we put them on it, right? They tune the neural network, et cetera. And then 6 months later, we declare victory and put it out in the field. I mean, that's been the model pretty much since day one. And the challenge of that, obviously, is that, well, how do you know when the model needs to be retrained? How do you know that it's not drifting? These are questions nobody really has very good answers for. And I think where we stand at the point of, and Alberto said it very well, because the way we're seeing the problem, we've developed this technology we call an edge cloud. I could go into it deeper, but the ability now to have compute at scale attached to every, I'll just pick on ultrasound, blood analyzer, gene sequencer, et cetera, where data's flowing into that thing constantly. And so why aren't we thinking about continuous learning and not batch learning? And this heavily is implementable through the work that actually began on the consumer side in federated learning. Your audience may not realize this, but Siri actually works this way. Siri's trying to become more accurate all the time. Well, it could be taking your voice print and sending it to the Apple Cloud. Okay, privacy questions, right? Like, what did you say to it? As well as who is going to pay for the network bandwidth to ship it there? And so on the consumer side, for privacy and network preservation reasons, the whole idea of learning at the edge has been, let's call it, pushed forward. Siri, Google Keyboard, we've actually spent time with the keyboard team, Alexa, etc. So can we take advantage, and we all believe we can take advantage of the technologies that were really developed for, improving voice recognition, and now apply it to whether it's cardiology, neurology, oncology, etc., so that we can not only learn while preserving privacy, but also learn continuously on a global scale. I mean, that's where we should be, not trying to batch it all together and do an experiment for 6 months.
Alberto?
Well, about the informed consent issues, one of the things that we forget all the time is that informed consent is communication, because we are used to paperwork in which we don't give much time to explain to the patients and the family what is inside. Most of the times, informed consent are written in legal, so very difficult to understand. Instead of having a clear communication process in which we tailor communication, we explain what is inside the process, we explain what we will do with the data and what will come out. So the problem with artificial intelligence is not explaining the technology or the equations behind machine learning or deep neural networks. The problem is making the people understand what are the risks and what are the benefits. And, even a pediatrician or a medical doctor should have the minimal knowledge for explaining that. I would add that not only medical doctors should have some information and some knowledge about that, but also the components of ethical committees, because when they review the scientific protocols for research studies, they should be aware of what's going on. All these observations tell me that we need more culture. One of the problems that we have is having people that understand a little bit more than simply perceiving artificial intelligence as an equation or a statistical tool for achieving some results. This is one of the challenges. And, one of the things that happen when you discuss AI with clinicians, they feel like you're offering to them something which is ready to use, and actually they can translate immediately in the clinic, which is not the case, because we must pursue very strongly the idea that we should work all together to develop the right artificial intelligence tools. Otherwise, we will be not doing the right thing. So having medical doctors, engineers, data scientists, statisticians, patients at the same table is one of the important things that we should be aware of. And once we do that, we will have not only better algorithms and better outcomes, but we'll also overcome several challenges and problems from the ethical point of view altogether. What's happening right now is that we are simply dividing all these competencies in silos, and we don't communicate with each other, which is bad.
Absolutely. Do you think that we would ever get to a point where actually the sharing of data is the de facto standard, and one would have to opt out in order to, rather than opt in order to continue with it? And, speaking as a parent, if I was knowing that the data that was collected from my child was de-identified, but then it was going to help other sick children or other children, and it was being used in that way. The articulation of that and being able to understand that as a de facto standard globally surely would make a difference, would it not, Tim?
Yeah, I just kind of want to play with the perception question. So I think a lot of times when we say sharing data and we say, well, all the data, et cetera, we have this vision. It's back to this centralized repository vision that it's all in one place. And if I could just crack the code on it, I will see everything I ever wanted to know about Alberto or whatever, right? And I think that's not what I'm talking about, right? I'm saying, and I just told you that, 10 of our Vanguard hospitals are generating over 150 terabytes of data every year. There's tons and tons of data flowing through this. And at the end of the day, and I think this is an innovation we have developed, we don't talk about anybody can use any data. We say the data must have a purpose, but what is the application specific purpose for it to then be authorized to see that data? So, I could say, well, David's running a project to figure out how to diagnose focal cortical dysplasia. I trust David. I understand what he's trying to do. I am willing, and when I say we talk about who owns the machine. I'm willing to share data with the David application. This is not a whole lot different. Your listeners, everybody has a smartphone. You can say Twitter can see my location, but not my photos, and Facebook can see my photos, but not my location. That's application specific data sharing. And I think we have to get people to start to realize that's what it's really about. It's not, there's some giant repository in the sky that's got everything in it. It's purpose built, right? And I think that's where it's a very different paradigm than the world that I think we've come from, which kind of rationalizes that, data is ultra scarce. It's actually not ultra scarce. Most of it's digital exhaust. It's just going into the air. And our ability now to be able to compute on it, vis-a-vis federated learning, or even share it. Even today, we've actually going to do a demo of what Anthony has called the birth of the pediatric internet, where we will have all 10 hospitals around the globe being able to share an image with each other of the doctors. We're asking all the doctors, because that's kind of the history of medicine. The doctors try it out on themselves first. So we're going to have Alberto scan himself, and we're going to demonstrate that on a global basis, we can do something like this, which is, I said, unheard of. And I think what we are trying to do, I'll say what Alberto and I are trying to do, is spark people's imagination for what now becomes possible, because that's really the thing that we need to have happen next. The infrastructure, I'll say we've done a lot of cool stuff. I'd be glad to talk more about the details of how we do this at scale with security, et cetera. But that's not the key. The key is the applications. And the applications cannot happen until we have the neurologist who's an expert in focal cortical dysplasia and the AI engineers in a team. That neither of them can function going forward without that. And I think that then touches on a big issue that we have not talked about, which is how the hell does all this get funded? The world of pediatric healthcare, it's sad to see. The NIH has a $42 billion a year budget. Only $2 billion is spent on kids. And out of that $2 billion, none is spent on AI. I live in the middle of the venture capital community here, right in Silicon Valley. No venture capital is going to invest in pediatric healthcare. It's not a big enough market. I'd rather solve a problem of a bunch of old people. So how do we make this transition?
Tim, I'll challenge you on that, because if you, unfortunately, you were probably asleep at the time, but we had John Parker speaking earlier at the conference about why we should be funding opportunities within pediatrics. So we need to probably get him over and do a roadshow around the Silicon Valley funders in order that we can make sure that they understand why it's important to invest in pediatrics. Let me just take this a moment. So we've got a little bit of time left, but if anyone has any questions, then please do put them on the chat, and for either Timothy or Alberto, and we'll put those across to them. We've got about 10 or so minutes left, so please do put those out there. Just while we're waiting for those to come through, there's a couple of other points that I wanted to just get some opinions on. One is very close to my heart, as both of you will know, and that is, how do we blend? We've been talking a lot about technology here and the importance and the opportunity that we have with technology. But how do we blend intuition? So the intuition, either as you, Alberto, as a clinician, or the a parent, you know, a mother, a father, who knows that child better than anybody else. How do you blend those two things together to come up with the best possible outcomes?
This is a matter of time, and I think we need time to understand better what is the balance between the two things. Because, you know, right now I would not actually decide everything on the basis of a clinical support system, for example, completely run by AI. Knowing that some of these systems are extremely accurate, especially when we speak of image analysis, for example. We all know several scientific papers demonstrating that melanoma diagnosis can be done much better by a computer than by a dermatologist. Having said that, I think that the two things should stay together always, even in the future. One thing is that we should accumulate some experience and understand what is the right balance between the intuition and the data coming from AI. But this should be not conceived as a as a separate thing. I think that the two things should stay together. So I feel like in the future we will see an augmented intelligence, not an artificial intelligence. Artificial intelligence is a tool that will help us to make the right decisions. We should also consider that right now, for example, we can have the best algorithm possible, but we can't put into the machine learning algorithm some of the variables that we have in our mind. That's something that we know very well. This might be possible in the future, but actually we should try to understand what is the outcome of the decision that we make together with artificial intelligence. Simply, we have to study and we have to keep on understanding, experimenting, understanding what is the accuracy, what happens when you implement artificial intelligence tools in the real clinic, and refine always the algorithms and the process, because, you know, it's not only the machine, it's how you use the algorithms in your clinical setting. And it might happen that the clinical settings are very different from each other. Everything is different if you think of a big, large hospital with several specialties and a lot of people with a lot of, very accurate capacity of making a diagnosis, where the human capacity is very important, and other settings where you don't have this capacity, and where having a tool like AI, which is accurate enough, makes a difference. So this kind of things should be studied and investigated as time goes by. And this is our job. So research about artificial intelligence is one of the important things that we should support.
Fantastic. Alberto, thank you. We have a question, Tim, and I'll put this to you, that's come from Paul Dimitri, who, as we know, is our host today. And it comes in two parts. One is, how do children's hospitals in the UK, and I guess anywhere else for that matter, but get linked into the Moonshot program? But I think actually the more important one in some regards is, we've discussed and you've talked about some of the vanguard hospitals that you've got set up, but how do we get some of the smaller, more rural hospitals integrated into this program when basic connectivity could be a problem for them at this stage?
Yeah, so I'll take the first one first. I'd say, Paul, just reach out. We obviously are already working with some areas within the UK, but we're happy to work with more of the hospitals there. So just reach out. We could start the process. I think to answer your question about connectivity, we engineered the entire edge cloud around a mobile first strategy. And actually did an experiment at Stanford Hospital on running a private 5G network because it was like, well, it looked like it could be possible that we could do this. And it worked remarkably well. And that's good news because the Stanford Hospital was built in an earthquake zone. So it has a ton of rebar in it, reflective glass, etc. So if it could work there, it can work pretty much anywhere. So 5G, and then we've actually already beginning a conversation about using Starlink. So there should be no area in the world that couldn't be touched. One of our Vanguard hospitals is the Gertrude's Children's in Kenya. So we wanted to go global on day one, right? And we're really pleased that Bambino Jesu joined. I mean, was basically was the first in Europe to go do this because we wanted to be global. That was by definition. Let me just take, because I know we only have a few minutes, so let me make one point because I want to leverage something that Alberto said early. We've seen this. There are a bunch of small groups out there who have taken limited data sets and built some promising algorithms based on that. And we would like to invite them to connect up with Alberto, connect up with me, et cetera, because we have developed what we call the Chang method. So this is in honor of Anthony Chang. And the Chang method is, okay, step one, let's take that cool, focal cortical dysplasia. I don't know why I'm on that subject today, but let's take that cool algorithm you might have developed with a small data set in Norway, okay? Let's take that, put it on the edge cloud, because now that diagnostic will see every ultrasound, MRI, whatever, as it flows through the network. Okay, which leads us to step two. Let's see how accurate it is. I mean, maybe we got lucky and it's really accurate at whatever it's trying to assess or measure. But if not, step three is let's use federated learning techniques to improve the accuracy of these algorithms. And I want to make the important point about this is the really difficult thing I keep seeing is the blending of the AI team and the clinician. That's where the magic is happening. And if we can find those, diamonds out there, and whether that's in Norway or California or whatever, and accelerate that into the network, that's the wonderful thing. And just to make a point, all those people who are working in adult medicine who might want to take what they know and apply it to kids, this is the perfect opportunity to go do that. There's a project we're working on with Stanford called EchoNet Peds, which actually the algorithm started out as an adult cardiology algorithm. And it's being brought in to children's medicine. So it's a way in which those of you who have spent time in adult healthcare might take what you're doing and applying it to, the billions of kids around the world.
Here. No, great point, Timothy. Thank you. Alberto, just in closing, give us a couple of minutes. Just what do you wish in an ideal world, in utopia, shall we say? What does pediatric healthcare look like for you as a clinician?
I think that we should reinforce the concept of multidisciplinarity, as I was telling yesterday in another conference, because we are still very disconnected. And you know very well a story that I'm passionate about. Some months ago, about 1 month ago, we actually participated in a ceremony where we presented a new movie telling the story of a family in which the father of a child with a congenital cardiac problem, changed his job to work to an algorithm for predicting complications in intensive care. And this tells me that we need not only multidisciplinarity, but a stronger partnership with patients. Because, patients don't wait, and families don't want to wait, and they push. And we as clinicians should respond to this pressure as soon as possible, because what I'm seeing right now is that, artificial intelligence is something that is outside the comfort zone and the knowledge of, my generation, because we have been working with other tools. We have to be open to the possibility of using these new tools, and together with other people, make the best use of that. And I think this will be my utopia in the short term.
Wonderful. And just quickly, Tim, if people want to contact you to get involved, then just remind us how to do that.
I'm in LinkedIn, as some people know, so that's really easy. I could give you my Gmail, or they could reach out to the organizers. I have a Gmail account as well that's easy to connect with, or reach out to you, David. You know how to connect with me.
Absolutely.
Yeah.
Absolutely. Please contact any of us if anyone wants to find out more. We will make sure that you're connected in the right ways. So it leads me to say there's a couple of bits that I picked up on that I think are really, really important to kind of leave with before I say thank you. Which is, one is we've actually talked a lot for a long time about the augmented intelligence, but I think it's still very, very important that everyone remembers that by bringing the best of human intelligence and the best of machine intelligence, that's how we get the utopia to a certain degree. The other one is that whenever we're trying to do anything along these lines, having the right purpose behind it and being purpose-built and purpose-driven, I think is, again, a fundamental piece. And finally, if we remember one thing, Alberto, you said that actually it's unethical not to be able to use the data that's at our fingertips. And again, I think if we take one thing away and we utilize that, then that to me is, success for the conversation that we've had. We know that the three of us could talk about this for a long, long time. We've got a given 45 minutes, which we're thankful for, but happy to extend the conversation anywhere else. And if I may, I'm going to put a little plug. So I host a podcast with my wife called the Not Many Adults podcast. If anybody would like to come on to the podcast, I'm very fortunate that I've had both of these gentlemen on the podcast. If anyone would like to join us on the podcast, it's our 4th season coming up. We'd love to have you. We'd love to talk about your innovation within pediatrics and how you're trying to change the world. So please reach out, let me know, and we'll move forward with that. But with that, thank you so much to the panelists. Thank you very much to Alberto. Thank you very much to Tim. It's been enjoyable as ever, and I really appreciate it.